For the purpose of this demo, please imagine that I'm a product manager at a gaming company. We've recently launched a new mobile game, and I'd like to analyze our telemetry to significantly enhance user engagement. No matter what the public cloud platform, building end-to-end analytic solutions is really hard, and project timelines are measured in several months. Welcome, Azure Synapse Analytics. Synapse is the next generation of the Azure SQL Data Warehouse, which blends together big data analytics, data warehousing, and data integration into a single unified service that provides end-to-end analytics at cloud scale. As you see on the screen, Synapse makes building these complex end-to-end pipelines into a simple, intuitive, visual, no-code experience. With Synapse, project timelines will be measured in hours and not months. In addition to empowering users to gain quick access and insights across all of their data, Synapse enables a whole new level of performance and scale that is simply unmatched in the industry. Let's take a look. What you see on the screen is our analytics application that's powered by Azure Synapse. Now, to essentially analyze end-user engagement, I need access to a variety of data, including the current engagement times, in-game click streams, application metrics, and telemetry data from our device partners. In short, petabytes of data. With the Open Data Initiative, accessing additional high-value data from systems like Adobe is really simple. Now, to start, I'd like to find out the longest playing duration of players per feature, where the total playing time is less than 20% of the average playing time, filtered by user demographics and add-on feature names. Now, this may sound like a simple query, but it's actually quite complex because we're accessing and joining data across multiple, very large, disparate data sources. In fact, a key part of Synapse is the ability to query both relational and non-relational data at petabyte scale, blazingly fast, using an ANSI SQL language. Let me issue the query against Synapse. Now, what's happening behind the scenes is the intelligent distributed query optimizer of Synapse is executing this query across hundreds of nodes in a fault-tolerant manner. Wow, it just took 9 seconds to execute this complex query against a petabyte-scale data set. Now, in the interest of some friendly comparison, let me run the same query against Google's BigQuery. Now, what I'm doing here is running the exact same query against the exact same data set running in Google's BigQuery. Now, as you can see, it's taking a little longer. Now, in the interest of time, we ran this query earlier. Any guesses on how long it took Google's BigQuery to complete the same query? 2 minutes? 5 minutes? 8 minutes, maybe? Let's take a look. It took a whopping 11 minutes. So for this complicated query, Synapse is 75 times faster than Google's BigQuery. Now, TPCH is a very comprehensive benchmark for analytics. The current state of art for TPCH is 30 terabytes. I'm really excited to announce that with Synapse, we've successfully run all the 22 TPCH queries in record time at 1 petabyte. Now, let's take a look at a different capability of Synapse. Query concurrency has long been a challenge for all analytic systems. Now, to showcase how Synapse empowers users with limitless scale, I have a dashboard here that compares it with the other offerings in the market. Now, what's backing this dashboard is a system that allows me to issue concurrent user access using industry-standard benchmark queries. Let's start with 50 concurrent users. As you can see, even with this fewer user set, Synapse, based on the query response times, is 3 times faster than Amazon's Redshift and 5 times faster than Google's BigQuery. How about raising the stakes a little bit? Let's go to 150 concurrent users. As you see on the screen, while Synapse continues to do great, we've hit the limits with both Amazon's Redshift and Google's BigQuery. Redshift starts queuing requests at around 100, resulting in significantly increased query response time and a vastly degraded end-user experience. BigQuery users actually have a worse experience. By default, BigQuery starts failing requests beyond 100. So if you happen to be the 101st user, you're out of luck. How about raising the stakes to true enterprise scale? Do you think Synapse can handle 10,000 concurrent queries? Let's try it out. Well, as I can see on stage, Synapse is easily able to handle 10,000 concurrent users. What you're seeing on the screen is it's working flawlessly with 10,000 concurrent queries operating on the system. Now let's take a look at a couple of additional capabilities of Synapse. As you see on the screen, we've deeply integrated Synapse with Power BI, making them the best combination in the industry. For example, you can build Power BI reports and enterprise-grade semantic models right from within the Synapse's workspace. With this level of deep integration between Power BI and Synapse, business users can gain insights that they need to make their data-driven decisions in a timely manner. Synapse also deeply integrates with Azure Data Share, enabling secure sharing of data and insights both within an organization and across organization with your partners with just a few simple clicks. Now, some of you may be wondering, what's the magic behind Synapse? Well, to achieve this limitless performance, scale, and true simplicity, we've completely re-architected the analytics stack on Azure from the ground up. Specifically, we've merged data lakes and data warehouses into a single system that essentially enables querying across both relational and non-relational data. We support true online elasticity through a cloud-native design that separates out our compute and storage layers so that they can be scaled out independently. We have intelligent multi-level caching, which leverages the memory hierarchy and SSDs in an efficient way to give you the best price performance for workloads of any size and scale. Our query scheduling is workload aware, and we support multi-master clusters over shared data sets, giving us infinite concurrency and scale. Finally, Synapse supports both a serverless query service and a cluster-based form factor for both Apache Spark and ANSI SQL, enabling all the analytic workloads that you can imagine. Well, a modern analytics platform, all this stuff is cool, but what about predicting the future? Isn't a modern analytics platform supposed to do that? Well, with Synapse's deep integration with Azure Machine Learning, you can scale out, build, and operationalize complex and very powerful machine learning models right from within the Synapse's workspace. Let me show you how. I'd like to predict the propensity or the likelihood of our user base actually buying in-game add-ons filtered by age demographic. Synapse enables me to do this by actually modeling a simple query that also includes native scale-out machine learning-based scoring on the Synapse nodes. Let's see how the query works. As you saw, the response times was near instantaneous, and I got my predictive analytics within Synapse. Synapse makes AI and ML really simple for our data professionals. Azure is the only public cloud that empowers users with limitless performance, scale, and insights. Analytics in Azure is simply unmatched. We can't wait to see how our customers use Synapse to digitally transform themselves.